Okay, so have you ever noticed how often people are like, just breathe when things get tough?
Right. We'd forget.
Exactly.
Yeah.
But you know what? I've been taking a deep dive into these anatomy notes and articles, one from the University of Rochester, the others from the Canadian Lung Association. And get this,
Mm-hmm.
our breath is way more powerful than we realize.
It really is. Breathing is so fundamental to life that we kind of forget how crucial it is. And not just for, staying alive.
Right.
It impacts our entire system.
It's true. I always think like oxygen in, carbon dioxide out,
Yes,
not
it's
good.
a
But hold on a sec. According to my notes here, our lungs are also like pH regulators.
Yeah.
Our lungs are multitasking. Okay, impressive.
It's all about balance. Think of your blood like a swimming pool.
Okay.
Too much carbon dioxide is like letting the pH get all messed up, right? And nobody wants to swim in that.
Oh, my.
But luckily, our lungs are like those silent pool cleaners, constantly filtering out CO2 and keeping things from becoming too acidic.
So I'm basically a finely tuned swimming pool. Got it.
In a way,
But wow. And this whole pH thing, that's got to be connected to why we feel so terrible when we're sick, right? Like our whole system is out of whack.
absolutely. Everything is linked. When we're unwell, that delicate balance is disrupted, and we feel even worse because of it. It shows how important those regular breaths are.
Okay, so I'm officially a lung enthusiast now. But let's get back to these notes. We've got this whole tour of the respiratory system planned, and it looks like we're starting at the very beginning with the nose. So it's not just for smelling those fresh-baked cookies anymore, is it?
Nope. The Canadian Lung Association article actually did a great job of explaining how our noses are basically air conditioners for our lungs, filtering, heating, and humidifying the air we breathe.
Wow, talk about multitasking. I mean, it's incredible how much our body just does without us even realizing it. Okay, so nose preps the air.
Hmm.
Then what?
Then it's on to the larynx, or as we like to call it in everyday conversation, the voice box.
Ah, yes, the larynx. Responsible for my beautiful singing voice and my, shall we say, interesting karaoke attempts.
Exactly. And your anatomy notes go into detail about how the larynx is made up of all these cartilages. The air rushes past them and they vibrate to create sound.
Wow, that's really cool. So those little cartilages are the real singers. We just provide the air.
Pretty much, yeah. And then from the larynx, the air travels down the trachea, better known as the windpipe.
Right, the windpipe. And here's a question I've always had. What keeps that thing from collapsing every time we inhale? Seems like a big design flaw, if you ask me.
That's where those C-shaped rings of cartilage come in. They provide that all-important structural support.
Ah, okay.
So no matter how much air you breathe in, they keep that airway open.
Those C-shaped rings are the unsung heroes. But okay, let's get to the main event. The lungs themselves. Tell me everything, starting with the bronchial tree. That sounds like something out of Lord of the Rings.
Picture this.
Hmm.
Your trachea branches off into two main bronchi, one for each lung.
Okay.
And then those bronchi just keep branching out into smaller and smaller bronchioles, kind of like the roots of a tree spreading underground.
I could visualize that.
Yeah.
But where does the gas exchange actually happen? Like, that's the whole point, right?
Exactly. All those tiny branches, they eventually lead to millions of microscopic air sacs called alveoli. That's where the magic happens.
So the alveoli are where the oxygen jumps on the red blood cell express and gets delivered throughout the body.
You got it. And at the same time, the carbon dioxide is like, see you later, and hitches a ride out on your next exhale. It's a constant, perfectly choreographed exchange, all happening right there in your chest.
It's like a microscopic dance party with oxygen and carbon dioxide constantly switching partners. It's way more exciting than how my old anatomy textbook described it.
Oh, I know, right? But it's not just the structure of the lungs that's fascinating. It's also the muscles we use to breathe. Have you ever thought about how your body actually does this whole breathing thing?
Well, I know my diaphragm's involved. Or at least that's what I blame every time I get hiccups.
The diaphragm is definitely the star player. Every time it contracts, it flattens out and creates more space in your chest cavity.
Oh, okay.
And that lowers the pressure in your chest. And when pressure drops, what happens? Air rushes in.
It's like physics is the reason we breathe. And then when the diaphragm relaxes, we exhale. So simple, right?
Well, there's a little more to it than that. Don't forget about the intercostal muscles. Those are the muscles between your ribs.
Well, right.
They help your chest expand and contract. They're like the diaphragm's backup singers, giving the lungs that extra oomph to take in air.
Teamwork makes the dream work. But what about when we're really pushing it, like during exercise?
Right.
Are those the same muscles just working overtime?
It's the same idea, but with a few more muscles joining the party. Your notes mention the scalenes and sternocleidomastoids. They come in when you need even more breathing power. They help lift the rib cage even higher, letting you take in even more air.
Wow, it's like a whole other level of breathing I've never even used before.
It's amazing.
And to think, it all happens without us even having to think about it.
Right. But as amazing as all that is, we haven't even talked about the real unsung heroes of the respiratory system, cilia and mucus.
Wait, mucus, as in the stuff I'm constantly trying to avoid, that's a hero.
Oh, trust me, it's a lot cooler than it sounds. Just think of your airways like a self-cleaning oven, constantly bombarded with dust and allergens and who knows what else.
Okay, I'm weirdly intrigued now. Tell me more about this whole self-cleaning oven situation.
So your airways are like the inside of your oven, right? Instead of baked on lasagna, though, it's all the stuff we breathe in every day, like dust and pollen and probably the odd cat hair.
Okay, maybe I shouldn't have skipped lunch before recording this. But seriously, what's stopping all that grime from building up inside?
That's where cilia come in.
Cilia.
Yeah, imagine these tiny little hairs lining your airways, waving back and forth like a field of wheat.
So like tiny little air traffic controllers directing all the gunk away from the lungs.
Exactly, and they work together, moving in these synchronized waves to push mucus. Yep, I said mucus up towards your throat. It's a pretty impressive operation, honestly.
Hold on, back up a sec. Mucus. Like the stuff I'm constantly trying to blow out of my nose, that's my first line of defense.
Think of it this way. If the cilia are the brooms, then the mucus is the dustpan. It traps all those particles that the cilia sweep up, stopping them from reaching your lungs and causing problems.
So like gross but necessary. Our bodies really aren't going for elegance, are they? It's all about practicality.
Exactly. And all this, the sweeping, the trapping, the transporting, it's all thanks to your nervous system, which, by the way, is basically the control center for your entire respiratory system. It's constantly monitoring and adjusting your breathing without you even realizing it.
Wow, our bodies are amazing. But how does it actually work? Does my brain just have a Post-it note that says breathe in, breathe out? Because if so, I think mine needs a reminder sometimes.
Thankfully, it's way more sophisticated than that. Remember those lecture notes you mentioned? They talked about the respiratory control center, which is located in your brainstem.
Yeah, vaguely. It's all coming back to me now.
Well, that control center relies on these amazing little sensors called chemoreceptors.
Chemoreceptors.
Yeah. Think of them like your body's internal bloodhounds.
Bloodhounds. Okay, now that is not an image I was expecting.
Well, they're constantly sniffing out the levels of oxygen, carbon dioxide, and the pH in your blood.
So if the levels are off, the chemoreceptors start barking. What happens then?
They send a signal straight to your respiratory control center in the brain, which then tells your respiratory muscles to either pick up the pace or slow things down to get things back to normal.
So basically, our bodies have a built-in system for maintaining the perfect balance. That's good to know, especially when it feels like everything else is out of whack. But what about those other receptors I read about, the mechanoreceptors? What's their role in all of this?
They're like the safety monitors of your respiratory system, making sure you don't overdo it.
Overdo it how?
Well, they're located in your lungs and airways, and they measure lung stretch.
Lung stretch. Is that like a yoga move?
Mm-hmm.
Because I'm not sure mine are that flexible.
Not exactly. It's just a fancy way of saying how much your lungs are expanding. So let's say you take a really deep breath, like a really deep breath.
Okay, inhaling deeply.
Those mechanoreceptors sense your lungs are getting close to their limit and tell your brain, okay, that's enough. Time to exhale.
So they're like a built-in safety valve for our lungs? Thank goodness for mechanoreceptors, otherwise I'd probably try to see how much air could actually fit in there.
Exactly. They prevent you from overinflating your lungs and potentially causing damage. And it all happens automatically without you even realizing it. Honestly, it's pretty remarkable when you really think about it. All the intricate processes happening every single time we breathe in and out.
I know, right? We've talked about everything from the tiny hairs in our noses to microscopic sacs in our lungs. It's mind-blowing. So to bring it back to the big picture, what's the one thing you think is most important for people to remember about their breath?
I think the thing that's really hit home for me during this whole deep dive is how much we take our breath for granted. It's such a fundamental part of being alive, and yet we rarely even think about it. But like you said, we're incredible breathing machines. Every breath is a testament to just how efficient and elegant our respiratory system really is.
Totally. But knowing all this, how do we actually put it into practice? How does understanding our breath on this level actually help us in our everyday lives?
That's the million-dollar question, and it's one we're going to discuss in detail right after the break.
Okay, so we've been on this wild ride through the respiratory system.
Pretty amazing, right?
Totally, from the tip of our nose all the way down to those tiny sacs in our lungs. But let's bring it back to reality for a sec. How can we actually use this knowledge to, improve our lives?
I think sometimes we need a deep dive like this just to realize how much we take our breath for granted. We only really think about it when something's wrong, but breathing is so fundamental to, well, everything. Besides the obvious, like don't smoke, what are some practical things we can do to actually take care of our respiratory system?
Well, that Canadian Lung Association article had some good advice. Like, one simple thing they stressed was hand washing.
Right.
Seems basic, but honestly, it's one of the most effective ways to prevent those nasty respiratory infections.
Can't argue with good old-fashioned hand washing. What else?
They also talked about air quality, especially if you're in a city or have allergies. Sometimes even the most impressive air filtration system, aka our noses, they just can't keep up with everything.
Makes sense. Those pollen bombs are no joke. But what about right here, right now? Anything we can do in this moment to help our breath? Remember how we were talking about deep breaths before?
Yeah.
Well, it turns out they're not just for show. Shallow breathing is a real thing, and it can actually work against us.
Really?
Yeah, you can end up limiting your oxygen intake.
Wow.
And it can even make you more stressed and anxious.
Okay, so you're saying those deep breaths aren't just for, like, yoga instructors and meditation gurus?
Exactly. Deep diaphragmatic breathing has tons of benefits. It can help calm the nervous system, it can improve digestion, and honestly, it just makes you feel more grounded.
Which makes sense, because it actually reminds me of something you were saying earlier about the link between our breath and stress. Was there more to that than I realized?
Absolutely. There's actually a whole bunch of research exploring that very connection.
Yeah.
And it seems like our breath isn't just a physical thing. It's also a really powerful tool we can use to influence our mental and emotional states.
Wait, are you saying if we learn to control our breath, we can actually control our stress levels? That's like next level stuff.
It is pretty incredible when you think about it. For example, meditation and mindfulness. Those practices often use conscious breathing techniques to help people relax and manage stress.
And it actually works.
Yeah.
It's like our breath is this bridge between our physical and our mental selves. I never thought of it like that.
I know, it's wild. It really highlights just how interconnected our bodies and minds really are. And when we pay attention to our breath, we're not just improving our physical health, we're opening up a whole other dimension of well-being.
I had to say, this whole deep dive into the respiratory system has been amazing. We went from basic anatomy to like mind-body connections, and it all comes back to these two amazing organs we just kind of take for granted.
I know. And to think, we're just scratching the surface here. There's still so much more to learn about the respiratory system.
Well, that being said, we'll leave you with this. What if, by simply changing how we breathe, we can not only affect our stress levels, but even boost our immune systems, or even think more clearly? It's definitely something to ponder. And until next time, keep breathing deeply and keep those questions coming.